We're asked to simplify each expression, rationalize any denominators when needed, and assume that all variables are positive. This means those absolute value signs we were just working on, yeah, we aren't going to need them on these. So when we're multiplying, all that needs to be the same is the index, and these are square roots. They have the same index. We keep the square root sign and then multiply the coefficients. 3 times 12 is 36. Y to the first times y to the 7th is y to the 8th. And then the square root of 36 is 6. And then remember our rule for the powers. We're going to take our power 8 divided by the index 2. It goes in 4 times, so it will be y to the 4th. We don't need the plus and minus out front. We don't need to worry about absolute values because we were told that everything is positive. So let's try number 14. Same kind of thing, it's multiplication. But this time we've got numbers out in front. So let's multiply those. 5 times 3 is 15. And then let's check each index. They're both cube roots. So we can keep that cube root. And then let's multiply these out. 4 times 32 is 128. And then x squared times x to the 5th is x to the 7th. So now we need to start breaking down this stuff. 128, I'm going to say that's 2 times 64. I chose 64 because on our blue sheets we'll notice that 64 is a perfect cube. So what's going to happen with that is the 15 is going to stay out front, and the cube root of 64 is 4. And I'm going to save a space. Then our cube root would have this 2 left over inside of it. And then same thing with our exponents. 7 divided by 3, power divided by the index, is 2 remainder 1. So out front we take an x, and it's squared. And then inside there was an x. Technically it's to the first power. I wouldn't write that most of the time. The last thing we need to do is multiply the 15 and 4. So we get 60x squared times the cube root of 2x. Moving on to number 15. We have a fraction, and so it can seem intimidating, but the first thing I want to do on here is simplify. So I look at 180 and the 5, the coefficients, and they actually divide. 180 divided by 5 is 36. So I'll put that up top. And I'm keeping both square roots. And then we have x to the 1 on top and x to the 7th on the bottom. So when we cancel one of them out, our denominator would have x to the 6th. And then simplifying the y's, we've got y to the 5th on top, y cubed underneath. When we cancel those, 3 would cancel out, and there'd be 2 left up on top. And then the last thing we want to do is take the square root. So the square root of 36 is 6. The square root of y squared is y. The square root of x to the 6th is x cubed, because the power divided by the index is 3. And that's as far as that one simplifies. Number 16, they're asking us to take the 4th roots. We can do this problem because both are 4th roots, the indexes match. So what I'm going to do with that one is, first of all, write it here so I have a little bit of room to work. I just rewrote it. And I need to multiply it by some fraction, some 4th root and another 4th root, so that in the bottom we end up with the 4th root of 2 to the 4th. The point is to get the power and the index to match. Well, this is 2 to the 1, so we've got 1, 2. But to end up with 4 of them, we'll need 3 more, because 1 plus 3 is 4. Then whatever we do to the denominator, we do to the numerator. So up top, we have the 4th root, and we have to multiply 9 times 2 cubed. 2 cubed is 8, so 8 times 9 is 72. And then if we simplify the bottom, we end up with the 4th root of 72 all over regular 2, because the power and the exponent are the same, so they cancel out. So when we reflect, we need to figure out where did this 3 come from, and we needed to have 4 2's. That's what we needed here in the end. And we were missing 3 2's. So then we had to multiply by 2 to the 3rd, top and bottom. Number 17, another great big problem. First thing I'm going to try to do is simplify if we can. And double checking, we both have cube roots, so the indexes are the same. So I'm going to have a cube root up top and a cube root on the bottom. Our coefficients 7 and 6 don't cancel, so I'll just keep them 7 and 6. We've got an x on the top and an x squared on the bottom, so that'll cancel out and we'll just have 1x left on the bottom. There's a y squared up top, a y on the bottom. Those cancel into just plain y. And the z squared cancels into z cubed, and we're left with just 1z on the top. So then what we want to do is figure out what cube root we're going to have to multiply by, because what we want to have on the bottom is the cube root of each of these. We need to have 6 cubed and x cubed. Well, to go from 6 to the 1 to 6 to the 3rd, we need 2 more factors of 6. And from x to x cubed, we need 2 more factors of x. Whatever we do on the bottom, we do on the top. And then what I'm doing here is I'm just multiplying. So 7 times 6 squared is 252, because it's 7 times 36. It's under a cube root. And then we have the x squared, and then plain y, and plain z. And finally, we just get rid of the root on the bottom. I'm going to say simplify the denominator. The top stays exactly the same. And the bottom becomes just plain 6x. And remember, nothing from the bottom cancels with the numerator, because the bottom is regular x, but the top is a cube root, so they don't play well together. So we aren't going to cancel them. So let's move on to addition. In addition, the rules change a little bit, because back here, as long as these were both the same index, we could multiply anything under the square root together. But in addition, in order to add radicals together, the numbers underneath have to be the same. And right now they aren't, so we're going to need to break down a little bit. So I'm going to break 40 into 4 times 5. And I'm going to do 80 as 16 times 5. And the square root of 5 does not break down. I'm not going to factor those any farther, because I know the square root of 4 is 2. We have 2 square root 5 plus 3 times the square root of 16 is 4, square root 5, minus 7 square root 5. I'm just going to clean up our middle term. 3 times 4 is 12, square root 5. When we put our like terms together, we just add the outside numbers. So 2 plus 12 is 18, minus 7 is 7. And when we're adding and subtracting, that square root underneath stays exactly the same. In number 19, we're asked to multiply. And so I'm going to distribute. 7 times 7 is 49. 7 times 2 root 3. Well, 7's a regular number and 2 is an outside number. So those get multiplied. So 7 times 2 is 14. We just hold on to the square root of 3. And then we're going to do negative 2 root 3 times 7. So the outside numbers get multiplied. Negative 2 times 7 is negative 14, square root 3. And finally, negative 2 times negative 2 root 3 times 2 root 3 is negative 4, square root 9. So if we clean this up, we have 49. This is beautiful because those two cancel out. And the square root of 9 here is 3. And 4 times 3 is 12. So we have 49 minus 12, which gives us a difference of 37. When we're squaring a binomial, it means that we should multiply it by itself. Now, some people can do these in their head and they know the answer. Good for you. I'm going to do it step by step. So distribute. Square root 11 times square root 11 is the square root of 121, but that's just 11. So I'm just going to write 11. Square root of 11 times 5, well, the 5 would be out front, and the 11 would be in the square root sign. And then distribute the second 5. 5 times square root 11 is another 5 root 11. 5 times 5 is 25. So when we put our like terms together, 11 plus 25 is 36. And because both of our square roots have 11 underneath them, we can add them. You keep the 11, add the front numbers. 5 plus 5 is 10. And our final problem is going to need a conjugate in the bottom to get rid of the square root of 5 plus 3. So we multiply the top and the bottom both by the square root of 5 minus 3. We always do the opposite sign from there. Whoops, square root of 5 minus 3. And so we need to distribute up in the numerator. That's going to give us 2 square root 5. 2 times 3 is negative 6. In the denominator, we need to FOIL. Square root 5 times square root 5 is square root 25, or 5. Square root 5 times negative 3 would be negative 3 root 5. 3 times square root 5 would be positive 3 root 5. 3 times negative 3 is negative 9. So the top is done. In the bottom, the square root of 25 is 5. The square roots, a positive, negative, cancel out. So we have a negative 4 in the denominator. And we can't really leave this with a negative 4 in the bottom. There are two ways to think about it. Whoops. One of them is to think of it as two separate fractions. So 2 square root 5 over negative 4. And then negative 6 over negative 4. So if we cancel these, 2 would go in 2 times. We don't like to leave a negative in the bottom. So it would be negative 2 root 5 over 2. And then here a negative and a negative cancel to be a positive. And we would have 3 over 2. So that's one way to do it. Or from here, we could say, I'm going to change both of my signs up top to a negative and then a positive, and then just kind of cancel each one in your head. So that'd be 1 square root 5 over 2. And 4 and 6 have a 2 in common, plus 3. Both are equally correct. Good luck on your review packet.